much. So let us quickly take a numerical from physics where a mercury solution is given to you. This is Hg, mercury. You know the representation of mercury is done by Hg, the chemical name. And a glass tube is inverted into this mercury which is submerged, right, with the open end down. This is the open end, and this glass tube, when you have seen in your school and outside, the glass tube is just sealed from one end. This is the same glass tube, test tube, right? Now this is sealed from one end, open from one end. This is submerged into the mercury, right, as per the diagram. Now how will the vessel in the vessel, the level of Hg will change, right? If the temperature is raised from 27 degrees C to 77 degrees C. So my dear friend, we are simply going to apply the Gay-Lussac's law, right? What's that? P1 V1 by T1 equal to P2 V2 by T2, right? So there will be two conditions, okay? First, as you have seen, the first temperature into the first case, the temperature is T1, right? And that is given to you as 27 degrees centigrade, right? And when you just change it into Kelvin, it will become 27 plus 273, which is coming as equal to 300 K, right? And into the second case, when it's given, the temperature is changing from 27 degrees C to the new temperature. What is the new temperature? T2. Let us say T2. It is given to you as 77 degrees centigrade. So this is 77 degrees centigrade. Now just convert this centigrade into Kelvin. So add 77 with this 77, 273, right? When you just add it, you get a value 3710, carry 1, 714, 115, carry 1, 2, 350K. This is the value of T2, right? This is the value of T2, and initial the value of T1 was 300K. So T1 and T2 are the temperatures of this mercury solution. So how this will be impacting the level of the mercury, we need to see, right? So into this condition, the question in the diagram you have seen that if you consider the level of the mercury into the beginning, okay, this is given to you as here the level of mercury which is just elevated inside the test tube is till 10 centimeter, right? So 10 centimeter. So what will be the, and this is the length of 40 above the level of mercury till the top of the test tube. This is 40, right? Then what is the level of air above the mercury inside the test tube? This one, 40 minus 10, 40 minus 10, isn't it? So if you want to consider the pressure, right? So pressure into the first case when the temperature is 27 degrees centigrade, so pressure, let us say P1, can be written as 76 is the normal atmospheric pressure which is applied over here and even over here, right? Not over here, because here we are going to calculate under the tube. So under the tube, here it is 76 mm of Hg, if you remember, right? It's 76, right? Now it's not mm, it's cm as per the question given into the question. 76 is on the level, on the layer of mercury which is in direct contact with the atmosphere. You got it what I want to say? Because this tube, unless except this tube, all the mercury is into the contact of the atmosphere. This is atmosphere, right? Outside atmosphere. So definitely 76 mm of pressure is will be applied over here. Now Inside the tube you can see 10 centimeter of this level of mercury is arisen by 10 centimeter. So what will be the effective pressure over here? 76 minus this 10, right? So P1 can be written inside the test tube at 76 minus 10, right? And this will be giving you 66 centimeter of Hg, not mm of Hg. Into this question, the value is in centimeter, right? So here we have T1, here we have P1, right? Now, if you remember the Gay-Lussac's law, P1 V1 by T1 equal to P2 by P2 V2 by T2, we are going to use that only, right? Now, into the first case, when the temperature was 27 degrees centigrade, basically 300 Kelvin, then the pressure was 66 cm of Hg. You understood how? Because 76 cm of Hg is the pressure on the mercury which is into the direct contact of the atmosphere. That's why I have written atmosphere over here, right? Atmosphere. Now, here inside the test tube, the level of the mercury is risen till a level of 10 cm, right? So that's why 76 minus 10, right? So this will be giving you 66 centimeter of Hg. So this pressure is when the temperature is 300 K. Now, what is the volume over here? If you consider the volume in the first case, the volume is the area of the cross section. Let us say if this is the area of the cross section, right? Let us say if this is the area of the circular cross section, A is the cross sectional area or cross section area, whatever you want you can write it, right? Then what will the volume, my dear friend? Volume of this pressure will be 40 minus 10. So let me write it. V1, changing the color of the pen, V1 will be equal to this 40 minus 10. This is 40 minus 10, right? So this is coming as 40 minus 10. This is the height. First let us consider the height. So this will be 40 minus 10 multiplied by this cross sectional area, isn't it? This will give you the volume. Tell me if this is wrong or if this is not understandable. Area into length. This is basically length, 40 minus 10, right? And you know length into area is volume. You know it. Volume is length into area. Now 40 minus 30 is 10, right? 40 minus 30. So initial volume which you want 40, not 40 minus 30, basically is 40 minus 10. Let me correct it. 40 minus 10. It is coming as 30. So volume will be 30 times the cross sectional area into the first case, and this is the value of V1. Now we have T1, we have P1, we have V1, right? So just think like this using the Gay-Lussac's law. What is that? P1 into V1 by T1 will be equal to P2 V2 by T2. The question was that, neglecting the thermal expansion of the mercury, we need to find how will the level of Hg will be changing inside the tube, right? If the temperature is raised from 27 degrees centigrade to 77 degrees centigrade, right? This was the question. Now, if temperature raised from 27 degrees centigrade to 77 degrees centigrade, into the second case, for just to equate for the as per the Gay-Lussac's law, we know that temperature is calculated. This is known. What is the volume into this case? My dear friend, let us say the mercury is rising till a level of x, till a level of x centimeter from this surface, right? If this is x, I am considering the second case which is being asked. If this is x, then you can see volume will be V2 here into this case. Let me put a line so that you can easily understand. This is the first case, this is the second case. So V2 will be, this X will be the layer of level of mercury inside it. So the volume will be, volume of the pressure over here will be A into this area of the cross section A multiplied by 40 minus X, because X mercury is region till X, right? So area will be simply A, this one, multiplied by the length, which will give you the volume, and that will be 40 minus X. And what is this X? What is this X? This X is, let me write it over here. X is the level of Hg in the tube, right? At T2, at T2 temperature. T2, that is 77 degrees centigrade or 350 K, right? 77 degrees centigrade. Now my dear friends, here we know the volume 40 minus X. This is entire length is 40. You can see this entire length is 40. This entire length is 40 from here to top of the close end of the test tube, right? This is 40 and this is X. So layer of air inside the test tube, which will be creating pressure on this mercury level, is 40 minus X, isn't it? So that's why we have considered 40 minus X as the length. This is the length and this is the area, and L into A is volume. We know it, right? Simple application of mensuration. Now, as to equate as per the Gay-Lussac's law, we know the volume. Volume is V2, which is 40 minus X into A, and P2. What is the pressure over here? That we have not calculated yet. So the pressure over here is P2 into the second case when the temperature was 350 K. So what is P2? So to calculate the pressure, the new pressure, here you can see 76 cm of Hg outside of the, on the external layer of Hg, which is in direct exposure to the atmosphere. Now when the layer of Hg, which is risen inside the test tube till x layer, till x centimeter above it, then what will be the pressure? Definitely 76 earlier atmospheric minus this layer, which is x, right? 76 minus x. This is the new pressure, right, inside the test tube, right? Where we have defined what is x. X is the level of Hg at T2 in the tube. In the tube, right? My dear friends, now we have T2, we have P2, we have V2. Just put it over here. So first writing the RHS, P2 is 76 minus X. Just write it. 76 minus X. What is V2? V2 is 40 minus X into A. 40 minus X into A divided by T2. What is T2? T2 is 350 K. 350 K. We have substituted the value of T2 into the denominator, right? Here, 350K. And into the LHS, we have P1, B1 and T1. What is P1? P1 is 66 because earlier into the beginning 10 centimeter of mercury already risen over here into the test tube. So P1 is 66. 76 minus this 10 because pressure which is created by the air inside the test tube, the length of this air is definitely 76 earlier 76 minus 10. So 66 is the only pressure inside the test tube. So that's why P1 is 66. Put it over here into the Gay-Lussac's law. P1. What is B1? 30 times A. A is the area of the cross section. This one. This is the area of the cross section, right? Which we have already mentioned over here. So B1 is 30A. Just write 30 times A, right? Divided by T1. What is the value of T1? T1, my dear friends, we have calculated 300K. So just write it over here. 300K. So my dear friends, whenever you solve it, we can see two variables A and X. But here all terms into the LHS will be in product where A is also into the numerator, and here also all terms into the numerator in product in RHS and A into the numerator. So A will be cancelled out. This A will be cancelled out, right? Now we have one equation. This 0 0 will also be cancelled out, right? 5 will be cancelling this 30 in 6 times and this 35 in 7 times, isn't it? Now when you see, this will give you an equation in form of x, right? Just solve to get the value of x, right? So that is the required length of the mercury. That is the required length of the mercury because at the temperature T2 77 degrees centigrade or 350 K, this value of x, in tube level of Hg at T2 will be your answer, right? And this will just solve it, my dear friends, right? Let me squeeze a little. So this will give you 6 will cancel this 66 in 11 times, and anything more? No, this 7 will be multiplying here. So 11 into 7 77 into 30. 77 into 30 is equal to 76 minus x into 40 minus x, right? And when you further solve it, this will be into the RHS. This will give you a quadratic, I can see, right? 76 into 40 and 76 minus 76x and this again minus 40x and then x square, right? So you can just solve it, my dear friend. 0 7 3 21 carry 2 2 3 1 0, right? When you solve it, right, constant, taking constant into one side, if you want me to bring the quadratic equation, I can do it. But when you solve it, you get some value of x. That value of x is the level of Hg at T2 above this, right? This will give you the level of Hg at temperature T2 of 77 degrees centigrade, right? If you want me, I can do it further. This will be 706424 carry 2 3040, right? And here 2310 already there. So just bring this 3040 into the LHS. So this will become minus and here into equal to 76x minus 76x minus 40x, how much it will be? Minus 76x minus 40x plus x square. It will be 106, 710, 116x, right? So this will be giving you further 116x so this will be giving you into the LHS. It will be just write LHS first. 0 minus 0, 0, 4 minus 1 is 3, 10 minus 3 is 7, 2 minus 2 is 0. So minus 730, and here minus 730 into the LHS and into the RHS minus 100 and minus 116x, right, plus x square, right? So when you just form the quadratic equation, it will be looking like this: x square minus 116x, and this minus 730 going to the RHS, so this will be plus 730 is equal to 0, right? So this is your quadratic equation which will be solved and you will get certain value of x, right? Certain value of x. Don't take the negative value, take the positive value of x, and this will give you this x will be the new mercury level, new Hg level at the temperature T2, which we have mentioned over here. In tube, level of Hg at T2. So this will give you, just solve it and get that value of x, and this will be your answer, my dear friends. Thank you so much for watching. Take care. Bye bye. Happy learning. See you into the next class.